Greetings, my name is Elijah Walker, and today we'll be comparing two methods for solving differential equations. Um, Method 1 is variation of parameters, method 2 is undetermined coefficients. We're given this differential equation, y double prime plus 2y prime plus y equals 4x squared minus 3 plus x to the negative 1 power times e to the x. The initial comparison is both require auxiliary and or characteristic form. So I did as such because m1 equals m2. This is the general form that we will get for the differential equation. Both variation of parameters and undetermined coefficients require that or explain that y is equal to yc, your characteristic, plus yp. For the method of undetermined coefficients, we use yp, which is our particular solution, and for my particular solution I use quadratic form of ax squared plus bx plus c. Taking the derivative twice, these are the two answers I came to. From there you plug it in to your original differential equation, and this is what I got. So cleaned it up a little bit, carried 2 through for the middle middle expression. And so you start solving for your a, b, and c. Ax squared plus is equal to 4x squared, so I got a equals 4. I carried this through for the 4ax. Once I knew the value of a, it was 4 times 4 times x plus bx equals e to the x over x. Solving that through, b equals e to the x over x squared minus 16. Did the same thing for the c and got c equals 21 minus 2 e to the x over x squared. You plug a, b, and c into your particular, and that'll give you your particular solution. And again, for undetermined coefficients, your y will equal your original characteristic from the auxiliary characteristic form, auxiliary form from the initial differential equation, plus your yp. For variation of parameters, your y of p, or a particular solution, is assumed to be u1 times y1 plus u2 times y2, where your y1 and your y2 is given by your auxiliary form from your original differential equation. There's a method called the Wronski to use. You can use to find your u1 and u2, and this involves taking your y1 and its derivative and your y2 and its derivative, putting them into a matrix and finding the determinant. For this one I got 0. I feel like my execution may be off. I believe my y2 may be missing something, but using this method you would find your u1 prime and your u2 prime. You would take your determinant, and for Wronski 1 you would make this first column 0, and once you made the first location 0, the second location would be the right hand side of your original differential equation. And then for W2, your Wronski 2, you would do the same thing on the other side, other column. So you would take your Wronski 1, Wronski 2, and they would both be divided by the solution of your original Wronski. Because mine came out to 0, this wouldn't work, which leads me to believe why I did something wrong here. However, once you find these two, you can integrate them. You multiply them by your original y1 and y2, and that's your particular solution. For some reason, if you don't like determinants, you can take the long way around and you find the derivative of yp and y double p, which is similar to the other method of determining your differential equation, which is undetermined coefficients. Once you plugged it in, you would expand your YP side and your right hand side. You'd solve for U1 and U2, and then you would do the same. You'd plug them in, and you would solve your original differential equation. Lastly, for my y, this is what it came out to. I'm going to have to double check it, but this is my final answer.